The planet J1407b is believed to have the largest ring system of any planet in the universe. Its rings are said to be 40,000 times wider than Saturn's, extending nearly 120 million kilometers. However, this isn't quite what most people think. For those unfamiliar, Space Engine is a 1-to-1 scale simulation of the entire universe, featuring nearly every known object. You can view J1407b in all its glory within the game, earning it nicknames like Lord of the Rings, Saturn on steroids, and Super Saturn. I made a video on my channel showcasing this planet in Space Engine. Hello and welcome to Z. Please don't forget to subscribe and hit the bell icon. Interestingly, Space Engine recently removed J1407b from the game, sparking curiosity and confusion, including from myself. I was just as surprised as you might be to learn that J1407b isn't real. Let me explain. This hypothetical planet has a long history. In 2007, astronomers first detected it through the Super Wide-Angle Search for Planets SuperWASP program. In 2010, Mark Picot and Eric Mamajek, apologies if I mispronounced that, observed J1407b passing in front of the star V1400 Centauri. They believed it had a massive ring system because the star dimmed for an extended period, 57 days, if I recall correctly, leading them to conclude that a ring system must surround this planet. This led to the assumption that J1407b was an exoplanet, or possibly a brown dwarf, with a huge ring system orbiting V1400 Centauri. This initial observation inspired the model in Space Engine. However, newer studies have revealed some intriguing findings. J1407b hasn't shown any more eclipses with its star. When astronomers expected it to eclipse the star again based on its orbital period, it was nowhere to be seen. This led to the theory that J1407b isn't a planet orbiting V1400 Centauri, but rather a rogue body that coincidentally passed in front of it. Moreover, the hypothesized massive ring system, 40,000 times larger than Saturn's, wouldn't be stable if it were orbiting the star. The rings would become unstable over time. I've created a simplified simulation of the original hypothesis. You can see the rings, though fewer in number, deforming over time due to the combined gravitational pull of the star and the planet. The star's gravity affects the rings, causing them to swirl and deform further over time. I'll let this simulation run while we continue and check back on it later. The most likely explanation is that J1407b isn't a planet at all, but a brown dwarf, which is between a planet and a star that happened to pass in front of V1400 Centauri. Initially, this seemed improbable because the chances of two such objects being so close were extremely low. This explains why astronomers initially thought it was orbiting V1400 Centauri when it was actually just passing by. Multiple observations of an object are crucial for accuracy. In 2017, the Atacama Large Millimeter Array detected an object near V1400 Centauri that they thought could be J1407b. This remains unconfirmed as of this video. The object's position was consistent with what would be expected if J1407b were a rogue system. Planet J1407b, a celestial body discovered in 2012, has captured the imagination of astronomers and science enthusiasts alike. Its unusual characteristics, including a massive ring system that dwarfs Saturn's, have led to speculation about its formation and potential habitability. However, recent studies suggest that J1407b might be a far more complex and enigmatic object than previously thought. The most striking feature of J1407b is its extensive ring system. These rings are estimated to be tens of millions of kilometers wide and are composed of dust and debris. Their sheer size and complexity have led some to speculate that they could be the building blocks of future moons. However, new research suggests that these rings may be a sign of a planet in transition. One possibility is that J1407b is in the process of forming moons. As the planet accretes material from its surrounding disk, the gravitational interactions between the planet and the disk can create gaps and rings. Over time, these gaps may eventually become moons. Another possibility is that the rings are the remnants of a collision between J1407b and another celestial body. If this is the case, the rings may eventually dissipate as the debris is accreted by the planet or ejected into space. In addition to its ring system, J1407b also has a highly eccentric orbit. This means that its distance from its host star varies significantly over time. This eccentric orbit could have a significant impact on the planet's climate and habitability. For example, if the planet's orbit brings it too close to its star, it could be bombarded by harmful radiation. On the other hand, if the orbit is too distant, the planet could become too cold to support life. Despite these challenges, J1407b remains a fascinating object of study. Its unusual characteristics provide valuable insights into the formation and evolution of planetary systems. As astronomers continue to study this enigmatic planet, we may one day uncover the secrets of its past and future. A deeper dive into planet J1407b, the enigma of J1407b's atmosphere. While the rings of J1407b have been extensively studied, its atmosphere remains largely a mystery. Given the planet's youth and the presence of a massive debris disk, it is likely that the atmosphere is still forming. However, astronomers have made some educated guesses based on the planet's composition and its proximity to its host star. One possibility is that J1407b has a hydrogen-dominated atmosphere, similar to the gas giants in our solar system. This would be consistent with the planet's formation from a disk of gas and dust. However, the presence of a debris disk could also suggest that the atmosphere may be contaminated with heavier elements, such as carbon and oxygen. Another possibility is that J1407b has a more complex atmosphere, perhaps one that includes clouds and weather patterns. If this is the case, the planet's atmosphere could be a source of valuable information about the early stages of planetary formation. The potential for habitability. Despite the challenges posed by J1407b's extreme environment, there is still the possibility that the planet could harbor life. If the planet has a suitable atmosphere and a stable climate, it could be a promising candidate for the search for extraterrestrial life. However, there are many factors that could make J1407b inhospitable to life. For example, the planet's young age and the presence of a debris disk could make it a dangerous place for living organisms. Additionally, the planet's eccentric orbit could lead to extreme temperature variations, making it difficult for life to survive. Future research. As astronomers continue to study J1407b, we can expect to learn more about this fascinating planet. Future observations may reveal the composition of the planet's atmosphere, the nature of its rings, and the potential for habitability. By studying J1407b, we can gain valuable insights into the formation and evolution of planetary systems.